And now we're going to go over the Unit 8 practice test on nonlinear functions.
Yay.
Number 1. That's my game show host voice. All right. Number 1. John is riding his bike. Select the graph that best represents John's speed over time. He increases his speed for 30 seconds. Well, let's see. Does he increase his speed for 30 seconds there? Yes. There? Yes. Here? No. No one should be talking, Lauren. Gosh darn it.
Sorry.
There? No. Okay? So, we've narrowed it down to 2. Okay, let's go to our next bullet. He stays approximately the same speed for the next 20 seconds. Yes? No. That's increasing still. So the answer is A.
Yay.
Number 2, a lot of you missed points at 2. Okay, let me give you exactly what I want. It's actually pretty simple. You don't need to get real wordy here. The graph displays the number of boat rentals. So this is March. This is October. Okay? The shop is open from March to October. Describe the change in number of boats rented over time. From March until about May, the number of rentals increased at a constant rate. I'll leave more space for you to, well, whatever. At a constant rate. Then the rate of rentals was the same or constant. So not constant increase or decrease, just constant. That means the same. Was the same or constant for several months. Then the number of rentals decreased at a constant rate until October. Okay, so you guys see how simple that was?
Yeah.
Okay, it's what happens in the beginning, middle, and end, using terms like increase, decrease, constant rate, constant. Right? So some of you are missing some of the proper verbiage. Okay, what is the comparison? Write a statement comparing the number of rentals at the beginning to the end. You guys are going to think that's so simple. Okay? There were more rentals at the beginning of the season than at the end. Then, yeah. That's it. Remember, more is a comparative word. More is less. How many more, how many less? We do that. Remember in the last test we had to do that? The rate of change was 9 more in the van than the semi and stuff. It's just a comparative statement. You guys do that all the time in science too. Okay, or you should. All right, number 3. The graph displays Carlos' height. Describe the change in Carlos' height over time. Increases at a constant rate? Yep. Increases more quickly? Yep. Then her height increases slowly at a constant rate? Yep. Then it stays the same? Yep. Answer is A. I think everybody got that right. Pretty obvious. Okay, B, or number 2, not so much. Just to hit a golf ball, the graph displays the height of the golf ball over time. The height of the golf ball decreases? No. So that's wrong. The height of the golf ball increases at a varied rate. Bruce, you need to pay attention to this. You're going to be, I don't want you to miss this. Does that increase at a varied rate?
Yeah.
And then does it reach a maximum, then decrease at a varied rate?
Yeah.
Okay. So the ones who missed this put C. If it increased at a constant rate, what would it look like?
Great.
Yeah, it would be like this. constant this, constant down. That's not what it is. It's varied. This varies. Okay? So, the answer is B. Okay? Page 3. True or false? The water temperature is increasing between hours 1 and 2.
True.
Whoops. Let me move that. Between 1 and 2. Yep, it's increasing. True. The water temperature is increasing between hour 3 and 4. Between 3 and 4, it's decreasing, so that's false. Most of you got the first two right. It was the last one. Okay? The water temperature is constant between hours 0 and 1. False. Constant is this. Okay? Now, if it was increased at a constant rate, that's different.
Oh, you got it right.
And then I said, okay.
What? Because you marked me wrong, so I got
I know.
it right.
And then I changed it because I realized it was
I
right.
actually tried.
That part, it was right. Yes. 3 points. So 3, let's go back and do that. Sorry, I forgot. So this page was worth 2. So far 5. This one was worth 1. And this one was worth 2. So 1, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, number 6. Now here's the dealio on 6. Okay? Everybody's graph should look like this, pretty much. Let me make this a little bit better. Well, let me just a minute. So I'm going to go ahead and group these. Okay? Whoop, I didn't mean that. I'm going to move that over there. Okay, I'm going to go ahead and group these. Okay. So there's a pot of water on the stove. The water is at room temperature. So I'm saying that's room temperature. Okay? The water increases at a constant rate. Water remains at a boiling point. Water decreases at a constant rate until it reaches room temperature, which is right exactly where it started. Then it stays at room temperature for a while. Okay? So it needs to look like that. Now, what if you started it down here? Is that wrong? No. Because you're the same room temperature down there. So that's a qualitative graph. It doesn't have quantitative data over here. It doesn't have numbers. So I wouldn't mark it wrong if you started down there, and I wouldn't mark it wrong if you're here. Now, it shouldn't be up there. Because if I think of boiling up here, then room temperature is going to be down here somewhere. But without numbers on there, you know.
So, like, we can have the graph, like, not like that.
It needs to be shaped like that, but I'm just saying where it starts over here could be different.
My graph like that, but you didn't mark me wrong.
I know. That's because I stopped because you'd already missed 2.
No.
Whatever.
I
Okay.
missed 1.
I'm not.
You just got that one right.
Then you got here. Yeah.
But I'm confused. You
I didn't even correct that one.
Yes, you did. Correct.
Okay, I don't know. I skipped over it.
So,
Okay. Number 7. The answer is no, because the number of pizzas does not increase at a constant rate.
Oh. Wait, what?
Or the cost of pizzas, sorry.
Yeah.
No, because the cost of pizzas does not increase at a constant rate.
Oh. Yeah. It doesn't rhyme like
Okay? So that's a no. That'd be worth 1 point. Right.
I didn't word it the right way.
Page 8, or number 8. Okay. So you can go ahead and all of these, and I did this the same. I'm just simplifying it for you. I did this the same on the test. You can just use these values for your inputs. Okay? And then I'm going to put it into the rule.
How many kids missed it on this one because they didn't do gravel?
I don't remember. Most people got these right. Some didn't have the right upside down one. So this would be 4 minus 2, 1 minus 2, 0 minus 2, 1 minus 2, 4 minus 2. So you get that symmetrical look. So negative 2, 2, negative 1, negative 1, 0, negative 2, and then it's symmetrical. And,
Yeah, I think I am too.
that's what it should look like. Some people miss points for not having arrows. That's worth 1.
I got it. Okay.
Okay? On this one, you would have negative 2 times negative 2 squared.
I'm on the wrong side. Oh, jeez. No, but I did it like that.
Okay? 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. 0, negative 2, negative 8. So negative 2, negative 8. Negative 1, negative 2. 0, 0, 1, negative 2. 2, negative 8. Okay? Alright, that would be worth 1 point.
Okay, so,
What?
so on the top one, I did, like what you did, but I got, like, one of the, what's it called?
Output?
No, I got one of them.
Yeah.
Different.
You made mistakes.
What do you mean?
You made mistakes in your calculations. Okay.
Oh,
Continuing on. 1, 1. Negative 2, negative 1, 0, 1, 2. Negative 2 cubed minus 2. Okay, negative 8 minus 2, negative 10. Negative 1 minus 2, negative 3. 0 minus 2, negative 2. Girls, be quiet please. 1 minus 2, negative 1. 8 minus 2 is 6. Negative 2, negative 10. Negative 1, negative 3. 0, negative 2. 1, negative 1. 2, 6. Okay?
Okay.
Woohoo. The next one, this is the one where I told you to put a negative 1 in front of your x cubed, minus 1, so you didn't make a mistake here. So if you did that, you should have gotten it right. And then it's just a matter of pushing buttons correctly, because you didn't use parentheses on your calculator. Okay, this would be negative 8 times negative 1 is 8, minus 1 is 7. Negative 1 times negative 1 is 1, minus 1 is 0. 0 times negative 1 is 0, minus 1 is negative 1. 1 times negative 1 is negative 1, minus 1 is negative 2. 8 times negative 1 is negative 8, minus 1 is negative 9. So we have negative 2, 7. We have negative 1, 0. 0, negative 1. 1, negative 2. And 2, negative 9.
I didn't do bad.
Okay? And the last page. Why is the first one linear?
Because it's the,
Y equals mx plus b. Or why is the next one not linear?
because it's a curve.
Because the graph is a curve. Why is the next one linear?
Has a constant.
X increases at a constant rate, Y increases at a constant rate. Why is the last one not?
Because they have, because too many numbers over there's too many out.
If I make a table out of the ordered pairs, do they,
Okay, what is it not have all the constant rate?
this decreases at a constant rate, but this goes the same, so there's not a constant rate over here. So that's a no.
Also
4.
the input and output.
Okay, and then the bonus, if this is time and distance from home,
Don't do it. Don't do it.
okay, so here you are at home, right? What does she do? She drove away from her house, so we usually increase at a constant rate. Then she came to a stoplight, so what's going to happen there?
So everybody's gonna go fly.
Okay, and then what? Farther away from her house, and then what? And then finally, the light turned green, she continued farther away from her house. So it should look something like that.
What if I did it going
Nope.
down?
You didn't- nor did you label your axes. So
What if the lines that are like that are, are they like straight or like that?
That's okay, because it doesn't say she's increasing at a constant rate. You know, if you're shifting, it's probably not a constant rate. Okay, did you guys come up with any other situations the graph could represent? Alex?
Anya was at the supermarket, she left the supermarket and went to her car, she started to head home, she came to a stoplight, sat there till it turned green, once it turned green, she started heading home again. She got to a stoplight, sat there at the light till it turned green, once it turned green, she started heading home.
So the same scenario. Any different scenarios?
A person walking up a hill and then stops to look around and then continues to walk up the hill and then stops again to take pictures and then continues to walk to the top of the hill.
So what is the, what are the variables?
Time and distance again? Yeah.
It still would be time and distance, right? Okay. All right, any others?
One is the person running, and then take a break in the gun, take a break in the gun.
Okay, all right, that works. Okay. All right, so there you have it. This will be on Google Classroom.
Gone.